So here look at the question. The strongest base among these. Here there are four options. Cl minus H3 COO minus HSO4 minus and NO3 minus. So which is the strongest base here? We should find out that. So to find that we should know an important condition, that is the stronger the acid, the weaker is its conjugate base. So if an acid is strong, then its conjugate base is weak. If the acid is weak, then its conjugate base is strong. So this is a very simple and important condition. And here you go. Let's find the acids here, like their conjugate acids. So what is the conjugate acid of Cl minus? It is HCl. Conjugate is very simple, differing by a proton. Okay, HCl and Cl minus differ by a proton. CH3COOH is the conjugate acid of CH3COO minus, and the next one H2SO4. If they ask you to find the conjugate acid of something, then it's simple. Just add one, okay? And NO3 minus, we get HNO3. Okay, for suppose if they ask you what is the conjugate acid of OH minus, then you should immediately say it's H2O. Okay, because just adding a hydrogen is simply enough. Adding a proton is good enough. Okay, so now let's go back to the thing. HCl is a very strong acid, so its base is obviously weaker according to condition. So Cl minus is not the correct answer. Then CH3COOH, it is weak acid, so it may be the correct option, because weaker the acid, stronger the base, stronger its conjugate base. Okay, and next one is H2SO4. H2SO4 is also a strong acid, so its conjugate base is obviously weak, and this is also not the option. HNO3, that's nitric acid. Nitric acid is also strong, therefore its conjugate base is weak. So this is also the not the option. So what is the correct option then? It's B, because CH3COOH is the weakest acid present among the following options. So all the acids here are strong, only CH3COOH is weak, so obviously its conjugate base is the strongest among these. So CH3COO minus is the correct option. Just remember this condition and that's good enough. Okay, bye. Similar question again. The strongest base among the chloride ion, cyanide ion, formate ion and acetate ion. So first let's write the chemical formula, molecular formula of these ions. Chloride ion is nothing but Cl minus. Cyanide ion is Cn minus. Formate ion is HCOO minus. And acetate ion is CH3COO minus. Okay, if you can't remember the acetate ion, then just remember the acetic acid. I think you're all familiar with acetic acid, right? It's CH3COOH. So if you remove a hydrogen from that acid, then you get acetate ion. Okay, this way you can remember the things. Formic acid, it's HCOOH. So if you remove a H from it, then it becomes formate ion. So it's very simple to remember. And now look at this. So I already discussed the condition earlier. The stronger the acid, the weaker its conjugate base. So here let's write the conjugate acids of the following things. Cl minus, the conjugate acid is HCl. Cyanide ion, conjugate acid is HCN. Formate ion, HCOOH. Acetate ion, acetic acid, it's CH3COOH. Okay, now remember HCl is one of the strongest acid that ever exists here. Okay, and HCl, so HCl is strong, then its base is weak, so this option is never correct. Okay, then HCN is a weak acid, so its base is strong. HCOOH is weak acid, then its base is obviously strong. CH3COOH is weak acid. So its base is obviously strong. So here we got 3 strong bases. But remember guys, which is the weakest acid? The weakest acid is Cn minus. It's weaker than HCOO minus or CH3COO minus. So therefore its base is considered the strongest. Because I already told you, the stronger the acid, the weaker its conjugate base. So here the strongest acid among this three is this one and this one. This is the weakest among all these things. So that's why the weakest is considered. So the weakest acid, strongest base. Okay. Now, so this is the correct option.